All right, so we've learned some good things so far. We took a look at why you might want to choose Go, and I think it's a fantastic language to choose. So good for you for selecting it. And we also saw how the Hello World program runs, and we learned all about the entry point, like how func main is the entry point to an executable program. So an executable program is a program that executes, right? That we could run it from anywhere. We call it an executable program. So we write that program, in a programming language, and then we compile it down to binary, zeros and ones, and sometimes wonder how rudimentary, how fundamental to get. And then that's an executable, and we could run it. So we saw how func main is the entry point to our program and how that needs to be inside package main. We learned about packages. And we learned about documentation, and then we saw how to do a Hello World program when learning about that. We saw how to use variables, and then also we saw the shorthand notation with variables, and we also saw how we could use var to initialize things to their zero value, and we saw format printing. And so, and how do we do format printing, and what are format printing verbs, and how do we print out the type of a variable to see the variable's type. So Go type is really important, and we'll see that as we continue working with the language. For a review, I have a couple of challenges for you, 3 challenges. And so these exercises are really good to do, just sort of solidify what you're learning. The first challenge is to create a program where you're going to have 2 different people. And you'll have a first name for each person and then an age for each person. So I want you to print out the name of age for each person, and then I also want you to print out the type of the variables for name and age, like what is the type, right? So that's the first challenge. The second challenge is to learn about zero value. And so I want you to find zero value at the golang.org website and read about it. So you probably look in either effective Go or the language spec. And then I also want you to initialize the following variables to their zero values, string int and float64, and then print the variable values after you've done that. And then the third challenge is to read about numeric types in the language spec. Read about numeric types in the language spec. All right, here are the answers. I'm going to give you the answers, so we're just going to go through those quickly. So we need to do 2 people, so you need to go do those challenges, pause this video, and then come back and watch the answers, make sure you got it right, or if you didn't know how to do it, you can see it. We need to create 2 people, so I could call, P1 name, right, for the first person, and then I could have, P2 name for the second person, and I could have P1 age for the first person, and I could have, P2 age for the second person, and, let's make something up. I'll do my dog Henry, whatever, doesn't matter, right? And now I could print out the types of each of those. So, P1, and then I could copy that, Control C, Control V, and this would be P2. And P2, and when I'm ready to just print those values, I could do, it's pretty similar, so we'll just do that here like that. And copy that. Copy that. Right there. And now when I run this, I should get everything looking good. Todd 40 string int Henry 14, what the heck, string int. And so printf doesn't insert a new line, and if I want to add a new line, I would add an escape character right there, escape sequence. And you can learn about escape sequences. Let's just run that, right? And now that did it. But that little special notation inside a string right there means put in a new line. And if you go to, I think it's inside the language spec, I don't know, it might be in effective Go, and I'm going to look for escape. And here we got rune literals. Runes are just characters, letters of the UTF-8 code points. And so that'd be like A, B, C, D, E, F, G. That's a rune, so on and so forth. And down here we have escapes. Whoa, that just got really big. I kind of liked it big, but there we go. And so here we can see, hey, /tab gives me a tab, or /t gives me a tab, and /n gives me a new line. And we saw that in action right there, so it gave me a new line. So that's how we do the first one. The next challenge was to do zero value, and we want it for string int and float64. So zero value, I'm going to use the var, and so var, and I could just do x, and that could be a string, and var y is an int, and var z is a float 64, and then I could print all those. I think I wanted to print the types too. No, it doesn't matter on that one. And XYZ. And run that. And here we've got 0, 0. And what? Where's the other one? Well, it'd be right there. It's just empty string, right? So XYZ, yeah, that's the first one. So that's where that one would be. And print the variable values, initialize the variables to their 0 values. So that's what we did with var. And then print the variable values. And then read about numeric types in the language spec. And so the language spec is right here. And to read about numeric types, we'd go up here and we have types. And so these are all the types in Go. And type is really important. You can see functions are one of the types. But here we have numeric types. And you come down here and you could read about numeric types. When I was first learning about the language and I came to this, I was like, holy cow. Go really wants you to be very precise, right? Like I'm now using an int 8 or an int 32. And if that's foreign to you, you'll learn about that in the fundamental section that's coming up. But the most important thing to know is that mostly you're going to use int, right? You'll just use int or float 64. Like those will be the two that you use. If you need decimals, you know, like 24.32, right? You have decimal places, you're going to use float 64. If you need int, right, like just 24, no decimals, you'll use int. And the thing that's interesting here and that illustrates how, you know, the documentation, language specification is very precise and every word has meaning, is right here. It says that with implementation specific sizes. Whoa, implementation specific sizes. So when you use an int, what that means, what implementation specific sizes means, is if you're using an int and you are running on architecture, a computer that has a 32-bit operating system word size architecture CPU, right? Like your word size is 32 bits. Like, you know, mostly, you know, if you don't know about that, old computers, you know, is 32-bit. And newer computers, 64-bit. And that's called the word size. And that's how many zeros and ones your CPU can process at one time, right? 32 bits at a time or 64 bits at a time. 64 bits, 64 bits, 64 bits. So if you're on a 64-bit machine, use int, then you're getting int 64. If you're on a 32-bit machine and you use int, you're getting int 32. And so that's just an example of the mechanical sympathy with which Go operates, right? The Go language was written. So it's mechanically sympathetic. It's sympathetic to the machine, to the hardware, to use that hardware most effectively. And if you use int, it's got implementation specific size. So kind of an interesting deal. The other two interesting things in the numeric type are that we have byte is an alias for uint 8, and a rune is an alias for int 32. So, you know, that's just also interesting. Runes, again, are characters, right? And a character is a letter of the alphabet. And it's int 32, which means it's 32 zeros and ones, or 4 bytes. And that totally corresponds with UTF-8. So it's all tied together. It's all beautiful. All right, so that's how we do those challenges. And we've learned some great things in this section. And I commend you for, you know, coming up and learning something new. And I encourage you to hang out with frustration, because anytime you're learning something new, there's going to be frustration. And that's just because, you know, like you're struggling, you're trying to wrap your head around concepts. It's new to you, right? And that's the way the learning process goes. But if you just keep showing up and keep working with it over time, you get it. I said this to my friend the other day. You know, I said, you know, I just keep banging my head against the wall, but eventually I make a hole. So that's how it goes. All right, see you in the next section.